Right. Good afternoon, everyone. Okay. Both online and offline. So today we are going to uh, discuss several things. Right. What I will discuss today. I will share my screen to you. So this is in Lentera, right? So we are going to discuss. This is what we have discussed so far, right? And last meeting we discussed requirement engineering. Okay. And today I hope we can finish these three. This is very strong will, so that we can come back to programming. Again, this is the programming. So I hope you can read this before the next meeting. Next meeting is 2 weeks from now. Right? Okay. And then in 16 May, you will create a progress report. Yeah? Again, 16. So yeah, that's 2 meetings from now. So next week we will next meeting we will discuss about object oriented, and if we finish, we can continue the next topic also. Okay. Okay. So today is the last part of the software engineering. We discussed about software development life cycle, so SDLC. Okay. So I come here. So you can follow this from the Lentera. So my goal to you is actually you're supposed to know what is the characteristic of software development life cycle, okay? And you're supposed to be able to state the characteristic, the strength and weakness of this software life cycle model. There are various models that we will discuss today. And why we talk about learning objective, that means these are the question in the exam. Did I record this conversation? Yes. Okay. Okay. So in this slide, I will discuss about this the following life cycle model. First is the code and fix. After that, the well-known waterfall life cycle, and then we talk about prototyping, open source, synchronous stabilized, and spiral life cycle. And then the next slide we'll discuss about agile, extreme programming. Okay, so this is what is called software life cycle. So software is like a human being. So it has birth, okay, and then you define it, and then you analyze these other steps, and then you design. After you design this, and then you develop. That is the coding part. The coding part is only this development part, and then you test. Okay, and after that you implement. That means you use. Okay, after you use, you maintain. Okay, and after some times, you can no longer maintain the software. Then the software is dead. Okay, so software can die also, similar to human being. Okay, so another way of thinking is it start with the problem. So last meeting we talked about requirement engineering. So from the problem you create a requirement document, right? The specification. After that you design it and you create what is called specification document. Okay, more detail of the requirement. So this one is talking about what. In specification, you talk about the design. That means how are you going to do that. And then this is the coding part. The program is the coding part, and then you do testing on that program, and then you have a working program, right? Once you have working program, then you do maintenance, after that, of course, the program will die. So SLC or SDLC, software development life cycle or software life cycle, is just the chronology of software engineering event. So if we look at this, we have three main phases. No? One is the definition, second is the development, and the last one is the maintenance. Okay, so when I start to learn this, okay, I start to realize software engineering is probably one of the core of computer science. Okay? This is the management of the software, and knowing this, actually, this is exactly what you need, okay, for doing a software development. So first thing first, you need to define, right? What is that software? So for definition, you have planning. So in that planning, you do scoping. Okay, what is the scope that you want to create? Okay? Say you are owner of a business, right? So you want to create a software, or you probably you have a software development company that you want to create software, okay? Or you are dealing with another owner, okay? And you help them to develop software. That's different scenario, but all the software development life cycle is the same. You start with definition, and then do development, and then doing maintenance. Okay. So in the planning, you do scoping, and then do budgeting. Okay. Estimate roughly how much is the budget, and then of course you talk about the schedule. Okay. Okay. Money first, time, right, and then what is the requirement, the scope, roughly. Okay. After that, we go to the actual requirement, the use case last meeting, remember? So you talk about functionality, what is the function, and then what will be the performance, right? There are some constraints in the design, so, and then how you validate this criteria, and so on, okay? These are the requirements. After that, you design the class diagram, and so on. So this is the UML more detail, okay? The procedure, how to test, and so on. Okay? This is the design part, yeah? And after that, whether in the same team or different team, you do coding. Again, that is based on the architecture, based on the procedure, and then you do testing. Okay? These are the development part. Coding and testing are integrated. Okay. Now, after that, you do what is called maintenance. This is what is often omitted by many people. So my question to you. Definition and analysis, sometimes this is what you call a development itself, right? This is the one that you think, this is the one that you develop. And the maintenance have three parts. You can probably have some bug correction, so there is some error that you want to correct it. After testing, this is already tested, and then you deliver to the customer. That is, there is still some bugs. And then you update, right? There are two types of update. Is perfective maintenance. So this will improve the performance of your software, maybe additional functionality. There is also called adaptive maintenance. So of course the environment change, right? The hardware change, that become better. Okay, and then OS, the operating system. Yeah. So before we have Windows 7 and then Windows 10, and now Windows 11 and so on. So there is a change in the environment. Okay, so that change on the environment, you need to change the software. Okay? So that part is called maintenance. Okay, and next, yes, go. What? Testing in coding. The testing below it. Where is the testing below it? Design. This is the test. Okay, this is the testing in here in design, or the testing in coding, and this testing below. Okay. So good question, Kenneth. Yeah. So this testing in coding here. Okay, you design the test. Okay, you design the test. Before you do coding, actually you're supposed to design the test. Strange. When you want to code something, say you want to code some function or you want to code some class, right? The input and the output must be clear, right? And then you need to tell, hey, for example, I give you a simple example. You want to calculate factorial. You need to know what is factorial of 1, factorial of 2, factorial of 0, factorial of -1, right? So these are the tests that you already put. You already created the design of the test. Okay, input this number will create error. Input this number will produce this value. Okay, these are this testing. These are actually the same thing. This testing and design and coding is the same. But this is the actual testing. Okay, testing in here is the actual testing. After you code, okay, you do testing. There are several testing. One is called unit test. Unit test means every class you test, every function you test. Okay, that is unit, every unit. And then second is acceptance test, meaning or integration test. The integration test means, say you have several people in the team, okay, creating different functions, right? Eventually, you need to combine into one software, isn't it? Right? So when you combine, okay, every function that you test is working. Unit test is working. But when you combine, it's called integration test. It's not necessarily working, right? Okay, so integration test. Okay, and then the next test is called acceptance test. The number 3 is the test that provided by the client, the business owner. Okay. Of course, they will talk in business term, and then you need to code that test. Okay. And why this acceptance test is important? Because this is where the money goes, right? Because if you can pass the acceptance test, then the business owner must pay you as the developer, correct or not? Right? So without this acceptance test, if you don't talk in the beginning about acceptance test, and then the business owner will keep bothering you, oh no, it's not finished, oh no, not finished, keep adding this and keep adding that, then you are in trouble, isn't it? Okay, if you don't know this procedure, you are in trouble. Why? Because you don't know the actual things, right? Then people will keep bothering you because your work is never finished. That is not the way, right? So what to do? When you create the requirement, you also design the test. Okay, these are the tests that I need to put. If they don't want to design the test, don't sign the contract. Okay, so they need to know when I will say that this software is finished, how you will accept this. Okay, okay. If this is the input, that is the output, right? If I give that input, that must be the output. That is the acceptance test. Is it clear or not? Question? So this is good for business. So if you don't know this, without testing, okay, your project practically can go on and on forever. This is not the way to do. Okay, so important to have testing. Yes, go. The testing in here is the design of the test. Again, this is the architecture process to testing. This is the design of the test. Usually, the design of the test mostly these three: unit test, integration test, and acceptance test. Okay, unit test, integration test, acceptance test. So test is very simple. You look, I know the input, I know the output. Okay, if the result of the output of the software is the same exactly as the output that I expect, right? Then it passed the test. Example like a while ago, you program factorial. Factorial of 1 is 1, right? Factorial of 0 is 1. Factorial of minus 1 is undefined. Must create error or warning, right? So if the user put input minus 3, for example, and it produce warning, that passed the test, right? If user put minus 1 and it give warning, that passed the test. Yeah. If supposed to be error, it's supposed to produce error. If supposed to have certain value, then it's supposed to produce certain value. Okay? So if the program do behave like what you expect, that means pass the test. In both, yeah, this is the design of the test. This is the actual testing. How do we? Yeah, this is how are you going to test it? What value you will input, and what is the output of that value? Before coding, yeah, before coding, you already know the test. In design here, you already know the test. In coding, what is this? You code that one. You code that testing. You want me to go to testing. Do I have? Oh, here. Okay, go to Lentera. There is a debugging and testing, and then it will go to my website. Right? Can you? I will share that screen. Okay, so if you go to my website here, debugging and factoring and unit test, you can read this. Okay, this is how you catch error and how you debug, and what is refactoring I will discuss later during Extreme. Okay, and the point is test-driven development. That means you need to create, you need to create the test before you develop the code. Can you read that? So I will make it bigger. You need to create the test before you create the code. That is the design. Okay. After that, you create what is called unit test. This is the coding. So the test is in the code. So this is example of unit test. Say, supposed to test like this. Okay. The answer should be equal to this value. Is it clear or not? Wait, I will. Okay, so clear or not now? Or per class or per function? Okay. You can also use unit test for acceptance test. You can also use unit test for integration test, right? Exactly the same. It's just the name is unit test because mostly you use for unit test. But the same procedure you can use because in here is basically you give the answer, right? And then you said assert equal, assert false, or assert true. So if you know the solution already, so you just, it will give you the actual test. Okay, this is an example of factorial. You show, I show here the example of the test. Huh? If you don't know the answer, you cannot make the test. Yes, of course. That's why you need to design it first, right? Okay. The test need to be coded, okay? That's why it's called automatic testing. Clear or not? Okay? Without this, you will start to see, oh, I will test manually like this. No, 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 that is not the way to do, okay? Not testing manual, okay? Testing must be automatic. And why? Because you need to do refactoring. Later we will discuss refactoring. So after here, is it clear or not the meaning of testing here? Yeah, this is like probably one of the most important part there. Yeah. So now this is actually only 40% of the life cycle. 40%. So what is the 60%? Maintenance. Okay. Maintenance is actually 60%. Oh, I did not share screen. Oh, sleepy. Oh, did I? Okay, so maintenance is the 60% of the life cycle. Okay? 40% is here. Development, analysis, planning. Yeah, this is 40%. So that's why if you want to emphasize, actually the emphasis must be in the maintenance. Yeah, yeah. So that my question. Intelligent guess. Yeah, how long you spend for each of the three main phases? Yeah? How much cost do you spend for the three main phases? Again, based on the cost, based on the man-month, okay, and how long? Again, the most significant part is actually the maintenance. Okay, so let's go to the detail. Okay, in definition phase, you have project scope and planning, and then you do what is called detailed requirement. You analyze, and you create the specification. Yeah. So in definition, first you estimate only, okay, the resources that you have, the budget and the schedule, right? So this is where you make a decision, okay? Say, for example, the budget is too big, the schedule is too long, or probably the resources is not enough for you, then don't go, right? How do you make decision based on historical data or empirical model? Yeah. And next is the requirement states. So in this case, you define the detailed function, right? What is the function? What is the class? Okay? And what are the performance that you require to make? Okay, and then you design what is the constraint of your program. Yeah? And again, validation criteria. This is the one that make the acceptance test. Yeah? Okay, so how do I know that this program is accepted, yeah? Valid? Important, right? This is very, very important. Okay, and after that, you go to the design stage, yeah, of the definition, which is software architecture, and go to the detail procedure, the class and the function inside. Yeah. So again, how much effort actually you do all of this? Yeah. In development phase, you have coding and testing, right? So in the coding, the issues is actually about what programming language are you going to use, right? So if you know Python, then of course you will use Python, right? No choice, right? So, okay. So, but look, if you are dealing with, for example, web page, of course, Python is only in the back end. Okay? Yes, there are some module that can help you in the front end, but mostly in the back end. Yeah? And maybe in the front end you will use HTML with CSS and JS. Okay? So some programming language is very good for certain purpose. Then you probably want to do that. So these are very difficult decisions. Sometimes company need to change their programming language. That means they need to train their developer for the new language. Yeah? Or probably there is not enough developer and the time is limited, then you force yourself to use certain programming language that the developer is already familiar. Okay, and next is about good style. Programming is about styling. So in Python, the style is already enforced to you, right? You need to put tab. Yeah. If after you need to put tab and then colon and so on. So this styling is already enforced in Python, but in other programming language, this is not enforced. Okay, you can freely put style, but that style actually will help a lot in programming, yeah? Because uniform style, especially in the team, will create a better reading for the program. The last part, but this is not least, this is actually one of the biggest problem, is to create documentation. Okay, documentation is similar to garbage collection. A city without garbage collection, what will happen? Right? So don't think this is less, okay? Because if you want to create a good maintenance, you need to create user documentation, developer guide. Okay? These are very necessary so that you can continue this project. Without this, example, my own program last year, I cannot remember. Okay? Because during this year, I create a lot of programs, right? The same thing with you. Okay? So after you work on different project and then you come back to that project, you will forget, even though it is your own code. Correct, Matthew? Right? So that's why documentation will help you. Okay? When after you code or before you code, you create documentation. Sometimes you will create documentation inside that code. Okay? So without documentation, you will forget, and nobody can use it. Okay? Including yourself, even though this is your own code, right? So this is very important, right? Okay, so and testing, yeah, testing state. You attempt to uncover the possible defect in the program, right? So most possible problem in the program, that is the one that you test. You don't test everything, but you just think of the latent defect that you can. Then you create what is called unit test. So, and once you create the unit test, okay, then you put this aside as the program that already tested, or some code that already tested. So you need to separate the code that untested yet with the code that already tested. Okay, and even if you already tested, this is still unstable. So this is alpha version, right? So after that, you go to other teams. Sometimes if your project is very big, there are certain people, their job is only to test your software. So they are called testers, software testers. This is a very big demand also in software industry, yeah? Software tester. So their job is only to test and create a unit test to create the automatic testing. Okay, and after the software is tested, so they put aside, assemble into working package. Okay? So again, you need to ask how much effort and time to do all of this. Yeah? So do you prepare the test before or after the coding? Yeah. The answer is should be before. Yeah? Before the code. Yeah? Why? Test-driven development, meaning if you create the test before the code, then you try to code just to pass your test. Simple, right? But if you create the test after the code, then there is no direction, right? The test is actually the design itself. Okay, the test is actually the one that created by the design to pass the test. So you code to pass your own test. That's why your test must be comprehensive enough. Okay? Clear? Question? Objection? Okay, so now we go to the maintenance phase, right? So there are what is called corrective maintenance. So in here you repair the error. Yeah? All software contain error. Don't worry if you get error and syntax error, whatever error you get from your software, that is normal. Okay, usual. Okay, even the most expert software, okay, in Microsoft, in Google, even in Amazon, the same. Yeah, they always create error. Okay, they are human being. Okay, so then you repair the error and then you create alpha release. Huh? Okay? And after you accept it, almost no error, you go to beta release. What is beta release? You already, alpha release is only for yourself usually. Yeah? Anyway, that depends on the software development lifecycle. But beta release, usually you already release to the customer. Okay? If you join Microsoft, sometimes before they release, okay, they will say, okay, this is a beta release. Do you want to join? Then you get the actual software from Microsoft for free because you are the one who tests. Okay? So this is basically testing to the customer. Okay? This is testing to their own developer team. So again, but if this is open source, totally different. Yeah? So even alpha release is already going to the customer. So next is preventive maintenance. That means you add documentation, right? You do commenting, you try to modularize. Okay, so that easy to understand. The code must be easy to understand. The near the beginners of programmer, okay, they will start to create the code that is complicated, difficult to read. Okay, that is I'm calling them beginners because they don't understand the meaning of maintenance. Okay, they just want to show off, right? Oh, my code is difficult, so that you cannot read. That exactly the opposite. Okay, when you want to create the code must be easy to read, full of documentation, so that any other people can read that and understand. Okay, because the purpose of the largest phase in software development is actually maintenance. Okay, so that's why we have what is called preventive maintenance. Okay, and next is update. Okay, again there is preventative maintenance and adaptive maintenance. Okay, any software always have new idea. Okay, either from you or from the owner, the business owner, that they want to improve, yeah? Adding functionality. Okay, so in fact there is a term called moving target problem. What is that? Before you finish developing, okay, the business already changed. Okay? Then totally different function that you need to do. Okay. Next is enhancement. Okay, so this is really big change in the requirement. Okay, that usually if this is too big, then the software is dead. So you can copy some part of this software for the next software, but you can declare this software is already dead. So you go to the next software. Okay, because the change is already too big. Okay, you cannot maintain anymore. Okay, sometimes easier to create new rather than to maintain. Okay, so this, you need to explain this to your client also, because sometimes your client cannot understand, right? Hey, you are the one who create. Why cannot you continue? Okay, especially if you're not the one who create, yeah, other people is the one who create that software. Eh? So you start to know. Here, this is the software cost. Development is just the tip of the iceberg. Okay, the larger part is actually the maintenance. Okay, so I put it into picture here so that you can start to understand the importance of maintenance. Yeah. So again, these are the relative costs or effort for various activities. You can see this is for the development and definition, and this is for the maintenance. So if we separate them, you see the testing is actually 45%, right? in here, half of this is go to perfective maintenance. Yeah. Okay, so let's start with the classical software life cycle. Yeah. Before that, is there any question, comment? No. Okay. So let's start with code and fix. This is what you are doing. Okay. What is this? This is a student version. Sorry, yeah. So there is no requirement, there's no design, there's no specification. Yeah. So this is a maintenance nightmare. So you get the first version, okay, and then you modify until the client is satisfied. Yeah? So basically, you do modifying always. That means post-delivery maintenance. Okay, until satisfied of the client, and then after you cannot do it, then retire. So this is the model, code and fix. We call this code and fix. Yeah. So you code and fix it until you retire the software. So easy, right? This is the easiest way to develop the software. It work well if your code is just 200 line of code, right? So this is practically programming exercise, okay? But remember, this is the most expensive way to do software development lifecycle. The most expensive and the most difficult to maintain. Yeah? And I put here the worst software lifecycle. Yeah? Don't do this. Okay? DDT. Yeah? Don't do this. Yeah? Okay. So then we know about that code and fix. Okay, the better one in 1970s, Royce proposed this. Yeah, this is called waterfall model. What is this? You start with requirement, yeah, and then you do what is called analysis, yeah? And then you do what is called design. Okay, and then you implement. That means you code. After that, you do maintenance before you return. Yeah? So every time here you can to change the requirement. So the change of requirement can go to the analysis, go to the design or implementation, and then can come back also. Yeah? This dash in here is meaning this is maintenance. Okay? So the actual waterfall model is just going down like this, like waterfall. Clear? So this is like step by step. Okay. Model of software. So, this is the most important part here. No phase is complete until the documentation of that phase has been approved by the SCA, Software Quality Assurance. So, the evaluator, SQA is the evaluator group, another team to evaluate the software. Okay, so this phase, there are several phases, right? So the requirement phase, the analysis phase, right? The design. So during the requirement, if the documentation is not approved, you cannot go to the analysis. That is the waterfall model is about. So it's fully documented. Okay? So you cannot go to the next phase until they approve. That is very long. Right? So, and then the modification of document is also checked by the SQA. So there is a feedback system. Testing is not separate phase, yeah, but throughout the software process. So everything here are tested. So requirement is tested by the SQA, right? The analysis is tested by the SQA. SQA is the software quality group here, the evaluator. Yeah. So you can be the SQA group also. So if you can read the code or you can read the specification, you can be part of that. Okay. So what is the characteristic of waterfall model? Yeah? Feedback loop. Yeah? And this is documentation driven. Some using DFD, some using UML. Okay. What is the advantage? Okay. The advantage is there is a standard series, right? The step is clear. Okay. So after the requirement, you do analysis. After analysis, you do the design. Okay. So that is to ensure there is no important area has been overlooked. Right? So those steps are very clear. And there is a clear contract, formal contract that you need to sign between the user and the developer. Okay? And this can go to the court, meaning this become the evidence for the dispute. Yeah? Okay? This still being used until today, okay? Especially the big project in military. Right? So it's suitable for large project, involve many people. Yeah? Many people, not any, many. Many. Okay, and then the discipline is meticulously checked by the SQA. Okay, maintenance is easier, right? Because of the documentation and check. Okay, what's the problem with the waterfall? Yeah, government project usually still use waterfall model. Okay, this is very traditional, 1970. Remember? Okay, the problem is too rigid. Okay, to the change of the requirement. And there is a problem of communication between the user and the developer because everything based on documentation. Okay, the user involvement in here is very poor. So if you want to change, difficult. Because, for example, you are already in analysis or in design. Okay, oh, there is a change in the requirement. Very difficult. You need to check back and then come back again with the waterfall. That is the drawback of waterfall model. Eh? So, specification, document, and diagram sometimes hardly understood by the user, right? You say boring. I reading all this specification document is boring. Yeah, this is not novel. So, specification diagram do not describe how the finished product will work, right? And then users sometimes just sign the document, but they don't actually understand. Okay, because of low user involvement. Okay, only usually during the interview in the requirement. So after they see the actual software, the working product, okay, has been coded, they will say, "I know this is what I asked, but this is not what I wanted." Yeah, it is often the case. Okay, so this is the problem with waterfall model. Then the improvement of waterfall model is to do what is called rapid prototyping. Yeah? So again, you have a requirement, but the requirement is based on rapid prototype. Yeah? Okay, so if you look at this, we have change the requirement into rapid prototyping. Okay, so you just create the GUI. You just create the fake functionality, and then asking the user to tell this is correct or not. And then everything else is the same as waterfall model. Okay. So nowadays there are many rapid application development to create prototype. Okay, and if you are a highly trained team, yeah, this is called SWAT, similar to military. So skill with advanced tool team, yeah, so they can create the prototype very fast. Okay, and there is a term is called time box. Okay, what is time box? Time box is a fixed time frame within which the activity are done. Okay, that means the requirements are sorted by the priority, yeah, and then agreed by the user, and then the developer will estimate, okay, the period of time to work all this functionality. For example, oh, I can finish this in 3 weeks, or I can finish this in 2 weeks. Okay, so and they need to deliver exactly what they say, right? Now, if they cannot finish within the time frame, okay, there is some risk on that, then some of the functionality will be sacrificed. So in that case, the user, okay, need to put the priority. Okay, if I cannot finish, which one should be sacrificed? Which function should be sacrificed? Within this time box. So every three, this is the improvement compared to waterfall, right? In waterfall model, you wait until everything finished, then you code, right? In here, no. They code it based on time box. Clear? Okay, so prototype is mostly GUI. Okay? There is no error checking, there is no real access to the database, there is no help file, right? Okay, and there is no options usually. Yeah? So this is just useful for the user to try out, react, to comment, and finally approve with confidence that this is what they want. Okay? Why? Why you need a prototype? Because they don't know what they want. So to overcome that, you create prototype. Yeah? So some missing feature can be added later on. Okay? So is it clear or not, prototype? Okay? So the advantage of prototyping is to improve the flexibility. Yeah? User can change the requirement during the prototype. Yeah? So it's basically more flexible than the watertype. And now the requirement become clearer. Yeah? If there is a problem, you can detect early, right? And there's some improved communication between the user and the developer in the end. So when prototyping is good, okay, when you have what is called in-house development. Yeah? So in this case, the developer are paid by time, not based on the project. Okay, why? Because if you pay based on the project and then the user or the client need to change all the time, yeah, again and again and again, then it never finish in the prototype, then never get paid, yeah, for the development itself. Correct, right? So in that case, developer will say, okay, I can do prototyping, but you need to pay me by time. Okay, fair enough. Okay, so the prototype will actually give the insight to the design team later. Huh? Question? Really? No question? So what is the disadvantage? Okay, because of the prototyping, you can extend the development schedule, right? And disadvantage requires some experienced teams to develop the rapid prototyping. Yeah? And there are tendency that the user make unnecessary change that do not improve the usefulness of the finished product. So this is the behavior of the user that we usually notice. And then nearly finished appearance or interface prototype may mislead the user thinking, oh, your system is already done. Okay, actually this is only prototype. Okay, we did not even analyze, we did not even design. Okay, this is only graphical user interface. But the user perception is different. They thought this is already done. It's still very far. So this is problem. Yes, go. Okay. Next software development lifecycle is called open source. Oh, now there's so many open source model, right? So can be extremely successful, okay, including Linux, for example, Firefox, okay, Apache, MySQL, and so on. Okay. Now become MariaDB. Okay. Yeah, you can check in GitHub, Forspoke, and so on. So, how is the open source lifecycle model? Okay, there are two informal phases. Yeah? First one is one individual, okay, probably you, will build an initial version. Okay, so made available on the internet. So if this is big if, okay, if there is sufficient interest in the project, so then initial version will be widely downloaded, and then the user, okay, or some of the user will become co-developer, okay, and then the product is extended. So majority of open source is not extended, okay, not reach even famous enough. Okay, so the key point here is individually An individual who work in open source generally work volunteer, unpaid, to create this open source project during their spare time, right? So the second activities is second informal phase is actually the reporting, correcting the defect. So this is basically the same as corrective maintenance. Right? The user is the one that report the bug. Okay, so and then the user is the one. Okay, I will contribute this part of the function. So they are the one who add some functionality. Yeah? Okay. And then the core team will be the one who add to that core program. Okay. Sometimes they said, okay, I will export this program to the new environment. So again, this is adaptive maintenance. Okay. Now, in this second informal phase, okay, is basically post-delivery maintenance. Yeah? So the word co-developer now become co-maintenance. Yeah? So if you look at the model now, I put it into diagram. What? First, implement the first version, and then you do corrective maintenance, perfective maintenance, adaptive maintenance, and then restart. Hey, look at this. Look at this model. What is this? This is exactly the same as the first one, right? The code and fix. Right? I thought the code and fix is the worst. But why we have open source model which is exactly similar and some are successful? What is the key idea here? Right? So there are something in common that the initial working version produced using rapid prototyping, code and fix, and open source. Right? In rapid prototyping, the initial version is discharged. Right? The prototype itself you don't use. Okay. In code and fix, okay, the initial version becomes the target product. Similarly with the open source. Right. So what make it better? Okay? How some of the open source project, right, has been so successful without specification of design? That is the good question, isn't it? So apparently here it is. Okay, in the closed source software, say Microsoft, software is maintained and then tested by the employees, right? So the user can submit failure report. Okay, failure means they observe incorrect behavior, but they never send fault report. Fault report means the incorrect source code. Okay, because they cannot see the source code, right? So they will never tell this source code is wrong and how to correct it. Okay, while in open source, because they are generally maintained by unpaid volunteer, okay, so the user is strongly encouraged to submit even the defect report, both failure report and fault report. This is the advantage of open source. Can you see that? It's the user that tells, hey, your code is wrong. Okay? This code contains some backdoor that people will easily hack. They are the one who report that. Okay? So basically there are two groups, okay? Two groups. One is the core group in the open source, which is just small number of dedicated maintainers, okay, with inclination and the time and necessary skill, okay, to submit the fault report and fix them. Okay? They are the one who takes responsibility for manage the project. Okay? They have also authority to install the fix. Okay? So you can create your own. Okay? And the second group, which is very big, is the one who use and then choose to submit the defect report from time to time. Right? So this is the advantage of open source, which is not enjoyed by the rapid or the code and fix earlier. Can you see that? That's why if you create your own program, I really encourage you, okay, to put it into open source. Okay. So the new version of the closed source software are typically released probably once a year, okay, after careful testing, right? So while the core group in open source, okay, practically release almost all the time. Yeah? See, you can see overnight build, right? The version is overnight build. So they just build it overnight and then release. Okay? Even if unstable, even if a lot of error, they will release. Okay? Why? Because they don't want to maintain. They just release so that people, the majority of the people is the one who report and fix them. Okay? So release early and often, that's the motto in open source software lifecycle. Clear? Okay, so the open source software production have attracted some of the world's finest software experts, okay, and they can function effectively without specification and design. So, however, eventually the point will reach that some open source product is no longer maintainable. Yeah? So, there are some restriction in the applicability, and you can see that not all projects open source are successful. Okay, myself, I developed many open source models. You can check by yourself in Google. So there cannot be an open source development of software to be used just by one commercial organization. Okay, the member of both core group and the peripheral are the user of the software being developed. Look at it this way. If you develop a software and then you are the one who use, every day you use it, will you improve it? Yes, of course. Because you create the software, okay, and then you are the one who use. Will you improve it? Because you use it and you feel, oh, this is not good. I can improve it this way and that way, right? Okay. The more often you use your own software, okay, the better improvement you will be. You got it? Okay. The more often you use that software is the one that make it more useful. Okay. So there are user power here. To be successful, okay, the project must be used by many people. Yeah, open source. And usually the user is also developer, and developer point of view, okay, you think that this is just to gain some skill, to gain experience for a better position later. Yeah? And some of these open source project, okay, developed by Suburb developer. Yeah? They have actually do a lot of winning project. Yeah? Then they can also do motivate the others to do the work. Yeah? So you see, Python is open source, right? So and many, including Linux, is open source. Yeah. So about half of the open source project on the web is not attracted to a team. So you can check how many teams there. And even where the work is started, sometimes they never finish. Okay. Okay. So, but when the open source model works, okay, it has sometimes incredibly successful, right? So, example, WordPress. Are you using? No? For blogging? No? Blogger. Yeah. So, open source product sometimes used by millions of users. Okay. Okay. So, next software development lifecycle is called synchronized and stabilized model. So it used to use by Microsoft. So this is commercial product, okay, and used in Microsoft. For example, in Microsoft, say Windows 2000, that's a long time ago, right? They have a 30 million line of code, LOC mean line of code. Consists of 3,000 programmers and reusing the previous version of the software. Yeah? So there is a requirement analysis. How to do that? They do interview of the potential customer, usually big company. Okay, and then they extract some feature of the highest priority from their client, and then they create the specification, and then they divide the project into build. So they call it build. Yeah? Basically a version. Yeah? Version 1 until 4. The first build consists of most critical feature, and then the second build is the next most critical feature, and so on. Okay? So based on the priority, which one is the most important feature, function that they need to do, and then it built and carried out by a small team in parallel. Okay? So here is the most important part here. That's why we call it synchronous and stabilized. For each end of the day, okay, the teams synchronize. Okay? So they do, this is the one that make it work. Yeah? Even though they have 3,000 teams member, why this work? Because every day they do integration testing. Every day they are doing integration testing. Okay? Okay. So the end of the build, so after they do every day, at the end of each build, say for example every 3 months, they stabilize this. That means they already integrate, okay, and then they freeze this build, okay, and they already fix the bugs, okay, and then they will say, look, I don't change this anymore. So this is called stable version. They freeze this, okay. If you look at the software, sometimes you download, right? What you will download? You will download the one in development or the one that is already stable. The word stable is actually come from here. So they synchronize and then they stabilize. Okay. Of course, you will develop. Unless you are a developer, so you want to get the one that's stable. Okay. Okay. So the component is always working together because they integrate every day. Okay. So look. There is no integration problem, but to do this, okay, you need highly talented manager and highly talented developer. Yeah? That's why in a big company like Microsoft and Google, okay, the pay is very big. Say for example, approximate. So one software developer will cost around 10,000 to 20,000 US dollar per month. How much that in rupiah? Yeah, 150 million rupiah per month. That's the salary. Right? And they have 3,000 of that. Okay? So why? Because they need to do it very highly stressful. Yeah? So they require discipline to fix the code immediately so that the rest of the team can test and debug, isn't it? Okay? So if there is an error, okay, there is a problem there, they need to fix on the same day. That is very stressful. Okay? So in software development, okay, there are many risks, right? So, for example, you create a team of software development, okay? So what happened? Some of your key personnel, say your best programmer, your best designer, probably resign before the product is finished. That is one of the risks, right? Or probably you need to use some hardware, okay? But that hardware manufacturing is already bankrupt along the way when you start to develop. Yeah, you already signed the contract and you require to use some certain software or certain hardware component, okay, and they are no longer available in the market. Yeah? So, or before the product is marketed, yeah, your competitor already announced first, okay, which is equivalent to your functionality and cheaper. Oh, doomed to failure. Yeah? Or some component does not fit during the integration. So these are example of risk. Okay, so you want to minimize the risk, right? Okay, other possible risks. So you are gathering the people, but your team is actually no experience in developing this software. So or you are not familiar with certain technology. Say, for example, your software required to do X-ray, for example. You are not familiar with it. Or you cannot hire people with the right background. Okay? So all of these are possible risks that you need to think. Yeah? What is the meaning of too fast company growth? No. Too fast company growth is like this. When you develop something, right, for that company, say the company is named A, okay? When you are still developing, the company already grew so fast that the requirement change, right? In that case, this is another risk. That means the requirement change along with when you are still developing, the company already changing. For example, before they don't have new branches, now they have several branches. Okay, and then now they require to have parallel processing, for example, that you don't know how to do. So this is an example of risk. Lack of user acceptance, right? So if they don't accept your work, then you never get paid. Okay, resources to shorten schedule, too many users, different. There's conflicting between the users and so on. So in the market also, if there are so many competitors, you are in trouble. If too fast enough, not too fast enough to market, you are in trouble because no. Yeah? And if you are too fast to market, is also a problem. Right? So both are problem. Yeah. Not fast enough to market. What does it mean? You create the software, not fast enough to market. Your competitor coming in first. Okay, with the cheaper, better, then you lost the market. Right? Too fast to market. What's the problem? The market is not used to. Okay, this is new thing for them, right? They don't want to use, right? So you need to educate the market. Okay? After you educate the market, someone else enter and spend that, then you're in trouble. Okay, so again, it's not as easy as just developing the software. Marketing is also part of it. Yeah. Yes, go. The way you market, you need to know who is your target market. If nobody will use your software, why are you going to use it? Why are you going to develop it, right? You think of possible risks before you create the software, right? And then based on those risks, okay, you think paranoidly about what is the possible risk. Based on those risks, what you will do, one by one, you will overcome that. Okay, how? If I have this risk, what should I do? Right? Knowing the problem is half of the solution. Okay? without discussing the problem, you always think positive. Oh, I'm sure I will get it. Yeah? It's a problem because you are too optimistic. Okay? So discussing the problem is part of the solution. That means you need to tell this is the risk. Okay? And then you start to overcome that risk before it happens. Clear?
It is possible to make software for sale in the future. So we make software first to the future.
You make the software first, what?
To sell in the future.
Of course, you make the software to sell in the future, of course. But before that, you probably want to test the market. Okay, so if you want to make a software that you want to sell, right? Before you make, in the defining the project, the scoping, right? So before you really do design the requirement and so on, you probably just test the market. Okay? So, is there any demand? Correct or not? Without this demand, then you okay, I'm sure this is a good idea, and then you just do it. You spend a lot of effort, you spend a lot of money, right? A lot of time on it, and then after that, nobody want to use that software. You are in trouble. So we have what is called MVP. Do you know? Minimum viable product. So this is the lean product development. Okay. So that means before you launch, okay, you test first. Say you create a very small prototype, right? Say this is not client based, okay? So you are the one who develop and then you will sell, right? So that means you create a small prototype, okay, and then you gather a few people, okay, someone that you know or someone that you probably don't know. Say your target market is high school student. Example, only example, eh? High school student. So you gather several high school students and then test them. Okay, you probably give them food or given some small money. Okay, can you test my prototype? And then give me the feedback. Right? This is the way to test. Okay? A few people test this software that you create. So you just tell this is prototype. Okay? And then based on that feedback, they will say, oh, I don't like this. Right? I'm supposed to have like this and like that. That is the one that you actually want to improve, right? Knowing the market, what the market wants, what the user or potential user wants. So what do you think? Is this useful or not? Right? Okay, without this, you will start to think, oh, I just want to code, I just want to create the software. Look, software is not just creating the software, Software must be useful for someone. Right? Unless that someone is you yourself. Right? Oh, I'm creating a software for myself. Oh, okay, then that is okay, right? It can be, yeah. For example, for your own personal growth and so on. There is possibility of that, right? So, is it clear? Yes. So, prototype can minimize that risk, right? So, before you deliver the product, okay, you do prototyping, okay, and then you create a kind of simulation, okay, proof of concept. This is not the actual system, yeah, and based on that you will reduce the risk, correct? Okay. Okay, of course, the risk on team, so for example, the team member will resign or incompetent, it is not addressed by prototyping. So that's another way to do, yeah. So in the management. Oh. So knowing the risk is important. Okay, Boehm, this is one of the well-known software developer in 98. He produced exactly like rapid prototyping. Okay. And he called this a spiral model. What is this? uh, in every stage, okay, we'll do risk analysis. In every state, you will do risk analysis. That is the difference between spiral model and rapid prototyping. It's clear? No? What's the spiral model? Okay, so the key point in spiral model is a rapid prototype waterfall model, right? With its phase preceded by risk analysis. Okay, so identify the sub-problem which has the highest associated risk and then find that solution of the problem. You don't identify the problem only, right? You prevent that problem from happening. So if all risk cannot be mitigated, then the project will terminate immediately before going further. Okay, so the full spiral model is actually incremental. Okay, so precede its phase by alternative and risk analysis, and then follow its phase by evaluation and the planning. Yeah? Something like this. So this is full spiral model. Say you start with requirement, right? And then you do risk analysis here. And then you do testing. And then get the acceptance test. Again, you do a risk analysis again, planning again. Okay, and then create the prototyping again, and so on. So this is the spiral model. Is it clear or not? So, of course, each of these phase represent certain feature that you want to develop. Yeah? The most important first. Okay. You don't need to have a full software that you want in order to sell, right? Certain part of the software already functioning, then you can already sell to get some reward, which is your profit or your revenue, and then you continue developing to the next feature. Okay, so this is the full spiral model is about. Any question up to here? Okay, so this is another way to do, see, more detail. Okay, so risk analysis, prototyping, concept operation, and so on. So continue to do that. Question? Okay, give me feedback then. What did you learn? Various software development life cycle, right? What did you learn? Hmm? The life cycle. What is life cycle anyway? So tell me what is life cycle. If you tell to your parent or you tell to your friend who does not get this course, how you explain this? Or you explain to your client?
The life cycle of the software.
Yeah, what is life cycle?
How to start, make them,
Mm-hmm.
how to improve them, and how they can like be good. Like when do we dispose them?
Okay, eventually you will maintain them, and then eventually the software will die. Okay, so next question is, which software development life cycle will you use for your project? Specific for your project. Right, that's what I want to ask. Learning all of these, okay, which SDLC that you will use. Okay, so yeah, this you can read by yourself. Okay, so different life cycle model has been presented with each with own strength and weakness. Okay, and of course the best suggestion is to mix them, yeah, and match with your need, right? That the model actually depends on the organization, depends on management, the skill of the employees, and the nature of the product. Yeah. So this is not panacea. Okay, so can you review what the difference between this software life cycle? Anyone? What are the difference between this? These are the software life cycle that we just discussed today. What are the difference? Yeah, okay, Billy.
So waterfall and the rapid, the difference is the difference.
The difference is in the
Wait. Okay.
you forgot. Okay, so okay, the difference is only in the
Using prototype with rapid.
right. It's just the prototype. Yeah, the requirement is changed by the prototype. Okay, the open source life cycle is look like the code and fix, right? Okay, but the two groups, okay, is the one that make it stronger. Okay, because it's open source, so people, the other group can, the user actually can maintain together with the developer. Okay, how about synchronize and stabilize? Right, so you integrate every day. Okay, and then once you finish, you stabilize, you freeze it as the stable version. Okay, box free. Okay, how about the spiral model? What's the emphasis there? The spiral model is not just a repeat. You know, the most important part there is the risk analysis. Okay, the risk analysis is the most important part of the spiral model. Yeah? Every part of the spiral need to do risk analysis. Okay, so if the risk is too high, you cannot do it, then don't do it. That's the meaning. Okay, if the risk is low, meaning that you can overcome, you can prevent, then do it. Okay. Okay, so yeah, do you want to have this risk analysis as part of your group project, or yes or no? No. Okay, so no is fine. Yes is fine. So you can include if you want. If you don't want, is okay, right? Okay, let's go to the next point, which is agile. Ah, yes. What? I cannot hear you. What? Oh, I don't know. Where is Stephen? Stephen is here. Stephen. Oh, Stephen, did you present your project? Otherwise, you will get 0.
For the project,
Hmm.
I have written like the first time.
Only first time. The second one you did not.
I haven't.
Yeah. So you need to present to me. Yeah. You set appointment with me.
Okay.
Okay.
Can I have your number, sir?
Oh sure. I think it's in the first slide in course syllabus.
Okay, sir.
Okay. Hmm. Okay. Let's go to the next topic, which is, so finish ya, classical order life cycle. So let's talk about agile and extreme programming. So this is like the latest one. Can you see my slide? Wow, 145. Can we finish it in half hour? Ah. Okay, I will skip many. The rest you read by yourself. I will just explain the most important part. Yeah. So this is somewhat new approach and somewhat controversial. Okay, and yeah, there are, instead of using use case, okay, they use stories. Okay, what is story? Story is a feature that the clients want. Okay, and then the developer will estimate the duration and the cost of each story. Okay, and then you select the story based on the next field. Okay, and then each field divided into tasks, right? And then you create the test cases for the task. Okay, that is one about stories. Okay, the requirement is, instead of use case, they use stories. In a moment, I will show you example. Yeah? And second, there is a talk about pair programming. Instead of one programmer, okay, pair programming means two programmer in one computer. What? Right? So this is somewhat controversial. Okay, but pair programming is proven that this is actually better. Why? Because one is programming, the other one is reviewing the program. So it become a bug free immediately. So, okay. In fact, the one that coding is the junior. Okay, the one that reviewing is the senior programmer. Okay, that's why they need to read the code without even coding. Okay? They need to review. And then the same as Microsoft a while ago, stabilize and synchronize, they do a continuous integration. Okay. So the computer are put in the central lab room with the cubicle. Okay. Another way of things that unusual in XP is the client representative must be always there. So the client, unlike the waterfall model where the client is only in the beginning, right? So in XP, if you want to use this software development lifecycle, you tell the client, if you want to use XP, yes, you must be here, or at least your representative that can make decision must be here every day. Okay, and then this is the several other unusual performance of XP. The software professional can work overtime for 2 successive weeks. So 40 hours per week only. Okay, maximum 40 hours. So, and then next, there is no specialization. Okay. Always have what is called refactoring. The design must be modified again and again, similar to the spiral life cycle. Okay, and there are several jargon here. Yakni, you are going to need it. So, okay, two simplest thing that possible work, and there are several principles in XP, yeah, that they want to minimize the number of features. Okay, so there is no need to build a product that actually does more than what the client actually needs. Okay. Okay, so I will just skip this part. You can read by yourself. Okay, this is the story of how they create the manifesto. Okay, so every day there is what is called startup meeting. Okay, in the startup meeting, the client representative is there, and then all the developer Attendance is required. So all the developer will stand, okay, in circle, and then they will tell what they are going to do today, right? Okay, what has been done yesterday, and then the client will tell them this is what is then needed to be done today. So with this kind of system, okay, the development becomes very fast. And the client, because it's always there, okay, they will get the software that they want. Can you see that? The difference. Okay. So instead of based on document and then go to sue each other in the court, okay, this is based on cooperation. Okay, between the clients and the developer. Clear, yeah? So in the startup meetings, these are the 5 questions. Okay? What I have done since yesterday meeting, morning, right? What I'm going to work today, what is the problem preventing me from achieving this, what we have forgotten, and what did we learn, and what I'd like to share to the team. These are the only 5 questions during the startup meeting, every day. Seems funny, but this is important. Yeah. Why stand up? Okay, because they want to finish the meeting as soon as possible. Okay, 15 minutes only. Okay, so to raise the problem, not to solve them. Okay, and the solution will be found in the next tomorrow meeting. So when you have a problem, we will solve it today. That's the promise. Clear? So this is important. So time boxing. Remember time boxing? What is time box a while ago? Oh, Tamara, what is time boxing?
Yes.
What is time boxing?
Giving a specific time constraint.
And then
Within which the activities are conducted.
correct. So within that time, okay, limit, okay, this is all the activities must be conducted. Okay, so this is actually successful management technique. Right? Within certain time, it's the time that you limit. You say 1 week or 3 weeks. Okay, and then we use this technique. Okay? So the point here is the communication between the clients and the developer. Okay, that is the key in Agile. Okay, and refactoring is very important part of software development here. What is refactoring? Practically, you change the code. For example, you rename it. Okay, you rename the code so that easy to understand. Okay, you rename the name of the function, you rename the name of the class, you rename the variable name, and so on, so that easy to understand. Okay, but you cannot rename, you cannot do refactoring unless you have automatic testing, right? Why? Because when you do refactoring, means you change something in your code, right? After you change, you test again. You run the unit test. You run the acceptance test. You run the integration test. Okay? So the testing is like you do it again and again. Okay? Every time you make a change in their code, you do automatic testing. Okay? So if something not pass the test, that means the last change is the one that create the problem, isn't it? Okay, the last change that is created. So it passed the test already, okay, and then you make change, okay, and then you test again. That's how you do in Agile. With that, you can easily detect the bug, right? That's why automatic testing is part of the refactoring here. Is it clear or not? Okay, so these are the agile process. Yeah. So what do you mean by agile? Okay. Of course, the ability to respond to the change. So that means, unlike the waterfall model or other model earlier, the classical one. Okay. So agile means if the client said, okay, I want to change this. I have a new requirement. The agile development said, yes, we can do it. Okay, so adaptability to the change of requirement is very big in agile. Yeah? So the rest is I just put. Okay, this is just okay. So the background. The background is this: if the design is good, why not make it into everyone's job, right? So there is no separation between designer and tester and coder, yeah, the programmer. Okay, so everyone will do design, everyone will do testing, everyone will do the requirement also. Okay, and then so there is no specialization. Next, if simplicity is good, why not use it as simplest design as possible? Okay. Because there is no specialization, right? The risk of one developer, the expert developer, go out of your team is no more. Can you see that? Right? Earlier in spiral model, we talk about how about if one of your developer is expert here and then suddenly they go out of your team before your product is finished. How you will alleviate that? This is the solution. Eh? You do pair programmer, there is no specialization, everyone will do the design, everyone will do the coding and the testing and the requirement. So everyone is equal. Okay? So if the architecture is good, why not everyone dividing and do the architecture continuously? Yeah? Okay, and the iteration, okay, is short. Yeah? If the short iteration is good, why not make the iteration very, very short? Hours instead of weeks or months. So one iteration is just hours or days. Can you see that? The change very fast. Okay, and then all these design requirement design are good. Why not to do it all the time? So they do code review all the time. They do design all the time. Okay, the requirement all the time changing. So how do you do requirement all the time? Stand-up meeting. Right? Every day there is a new requirement from the representative of the client. How do you design? Refactoring. Right? You change the design. How do you code review? Pair programming. Can you see that? Okay. How do you testing? Testing is good. Why don't even do it all the time, even for the customer? How do you do that? Automatic testing. Okay. So integration testing is good. Why not do it several times in a day? So again, all of this require automatic testing. Clear? Okay. So the iteration of software is very short. Okay. So short iteration usually 2 to 6 weeks. Working version at the conclusion. Yeah. And very adaptive. They can change. And again, people centric. Yeah. The development management and the client are equal. Okay. So this is the one that make agile or extreme very attractive. So remember, this is the cost of change in different stages. Remember, if the change in requirement, then it's very small. If the change is in analysis, during the analysis stage, right, then a little bit bigger, right? If the change is in the design state, become bigger. implementation become much bigger. And after the testing, if you make a change, that will become very big. Okay? And after production, okay, you make a change that change is very big. So, but in agile, we make it flat like this. Okay, so all the time, okay, the cost of change is actually flat. How? Okay, so that's the key here. Okay, so let me go to the definition you read by yourself. Okay, this is okay. You can read by yourself. Oh, yeah. This is important. So this is called iterative and incremental. Okay, in XP we have iterative and incremental. So there is a time box cycle. Okay, and this is the rhythm. Okay, so say you have a product, right? So one product consists of many releases. Okay, the jargon first, you start to understand. Every release consists of many iterations. Okay, every iteration consists of many tasks, and every task consists of many episodes. Clear? So you divide big things, one product, into several releases. Yeah? So say one product, so you have say 2 or 3 releases. That means one release is probably 6 months. Okay, say if you want to make it 1.5 year or 1 year. Okay, and then one release consists of many iterations. So that means one iteration is probably 1 month. Okay, or 2 weeks. Right. So and then each iteration consists of several tasks. So that task probably several days. Okay? And then each task consists of many episodes. So that episode can be hours. Can you see that? Okay? Or minutes. Okay? So that means you break down the actual product into small detail, okay, until you can do it within minutes or hours. Can you see that or not? Okay, so you break down again the product. This is the requirement and the priority, and then you release. So release means again you prioritize the stories, and then you make the iteration. Again you break down, and so on. So the primary deliverable of the clients, okay, consists of stories. Probably I want to explain that stories. Wait, I will just go to the example. Okay. So these are the 12 practices of XP, extreme programming, okay, that eventually will make synergy. Okay? 1 + 1 is not 2, but many. Okay? So these are the important part here. Okay, let me explain to you what is this about. Okay, so on-site customer, every day you have stand-up meeting. Okay, the goal is to identify the item to be accomplished today and to raise the issue. Yeah, everyone must attend, including the customer. This is not discussion forum, just that 5 questions a while ago that I explained. Yeah, just 15 minutes. Okay, so and the whole team, yeah. So the small team, say maximum 15 programmers, okay, and in the same space, okay, during working hour, okay, the important here is a face-to-face communication, yeah, offline. Sorry, so you need to have no disruption, yeah, no phone and no texting and so on. So just 15 minutes. Okay, and they must commit 100% to the XP practice. Yeah, and why on-site customer? Because we will create the stories, yeah? User stories that are not detailed. You can ask the customer, okay, the representative of the customer. So the customer must always available to resolve the ambiguity, yeah? To set the priority and to provide the test case. So these are the job of the customer representative, the three things here. Yeah? So for example, I'm not clear about this user story. What do you mean by this? They must be able to answer that. And then among this user story, which one you prioritize? They need to answer that. Okay? And then what I will do to make this test so that this can be accepted, yeah, for that its user story. So customer is part of the team in this case. Yeah. Look at this planning game. This is important. So each feature requirement, right? Each feature is written out as user story. Okay, what is this user story? Just paper. So this is the one paper I divide into 8. Okay, small as this. So 4 by 6 inch. Right? So, and then you write, as a client, you write 2 or 3 sentences in this small piece of paper. Okay? What is the requirement? One user story. Okay? What feature? Okay? Can I have an example before I come back here? Wait. Example, this is a simple project. Okay? Say just create a, login authentication. Yeah? This is just example only. Create a member page. So, and this is example of user story. In the jargon of the business, okay, some page trigger login mechanism, some don't. The list of pages that don't or do is dynamic. The mechanism is trigger once per session. Okay, this is the story created by the client. Okay, and then the developer will say 1 day. They will do this in 1 day. Okay. Okay, and the same thing here. When the login is triggered, the on-site cannot detect user or member, blah, blah, blah. And then the developer will estimate the time, 2 days. Is it clear or not? Okay, so, and username must be email address, example. So, there is nothing to do, right? So, the developer will say, this is constraint. No need to estimate the velocity. Right? So, this is example. After you create that user stories, right? Okay, and then you will ask the client to prioritize. Okay, oh, this is short term, this is immediate, this is long term wait. Okay, so they need to prioritize which one is important for you to create this time for this iteration. Okay, and then, so after that, from the stories, okay, the developer create what is called task. This is example. So look at the example. If read log cookies, if present display login, blah blah blah, and then bring up login page and so on. So this is clearly the word of the developer. So the design is already in the task, also in the user. Clear or not? Yeah, this is another example of login task, right? And then each task you give number, and then you assign who will do this. Yeah? And then each programmer who will do this will estimate the ideal hour. Okay, I can finish it in 4 hours. I can finish it in how many hours? And then you total, right? Okay. Can you finish within that time box or not? Right? So after that you track the information. Yeah. So say after one iteration, you start to check. Okay, this is the actual hour, and then what is the actual? This is the estimate hour, ideal hour. Okay, what is the actual hour? So you can start to check based on this estimate and the actual hour that you spend. You start to know your own speed, isn't it? Is it clear? Okay. So this is the actual things, yeah. So the user will P in here is the user, T in here is the developer, yeah. So the user will write the stories, and then the developer will estimate that story. Okay. If they cannot estimate, that means the story is too big. Okay. So you need the business, the client need to separate, yeah, split the stories. After finish this estimate the story, what do you do? The business people will sort by the value, okay, and then the developer will sort this by the risk and velocity, okay, and then the business people will start to choose the scope that they can finish within the time box. Clear or not? Okay, okay. So after that they implement. Yeah, this is to pick the story to be implemented first, right? By the B means the user, right? And then they start to create the code here. Clear? Yeah? After that, they run the test. Yeah. Okay. So if they cannot finish, not accurate, then they re-estimate. Yeah. So if they finish, then you create a new story, and then go to the next story. So, is this clear, the way to do? Yeah? So probably you want to use this, I'm not sure. This is quite adaptive for you, if you want. Yeah? For your group project. So what is ideal hour? Yeah? The amount of work that you can complete in 1 week, during which the phone does not ring, there are no meeting, you don't have to work with anyone else, nobody bugs you, and you aren't sick, you don't have a hangover, you don't hunger, and you're always alert, and you see the pig fly. Eh? So these are the ideal programming week. Okay. So this is just a comparison, you can read by yourself. So I think those are the most important part in this XP. Yeah? And the next time is the frequent release. I think testing, yeah, I already explained a while ago. Most important is to have automatic testing. Yeah? Without automatic testing, you cannot redesign. Okay? You cannot do refactoring. Yeah? So that is very important part there. So unit testing is part of the XP. Okay. So part of this class, I require you to, in your group project, to have automatic testing, right? Okay. You check the core syllabus, that is already there. Okay. In the beginning of the design of this class is already there. Okay. So please check. Using automatic testing, you can do a lot of things. Eh? Okay, so you just read all of this by yourself to deal with this XP. Any questions so far? No. Okay, sure. Yeah. Okay then. So I think the rest you can read by yourself. I think it's really simple, right? What is refactoring? That means the change that you make the internal structure of the software to make it easier to understand and cheap to modify. Yeah? So basically, refactoring represents the design. Okay. So you change it even if not broken. Even if there is no error, you still need to change. Yeah, useful name. Yeah, you remove the duplication in the code. You try to abstract it and so on. Yeah? So that the code will become better and better. But to do that, you need to have automatic testing. So you test to guarantee that the refactoring does not break anything that already works. Okay, so we call this design through refactoring. That means the design itself is actually refactoring. Yeah. Okay. So in that you have no question, I think I will end this class and this topic. Okay. So the rest you can read on your own. Yeah. Yeah. Okay. Is there any question? Sia, are you still there?
Oh, yes, sir.
Disappear.